Good afternoon, everybody. Just waiting on Jan. Oh, perfect. I see Jan now. Let me and the co-host. Yes. And Pan Jan's. All right. While we are waiting, anybody got any questions about anything? We good? All right. I'm going to mute and get out of the way and turn it over to you, Jay. Good to go.
Thank you. That's why 1 minute while I switch audio. 1 minute.
You can take your time and to get the audio set up. It's no rush. All right. Yeah, just take your time. No problem.
All right, and everyone still hear me?
Yes.
Your audio is perfecto.
Okay, great. Um, okay, good. I'm glad everyone can hear me. If you have your tables labeled already, you'll see table 1. Is someone saying something? I'm just hearing feedback.
I think there may be somebody in the lab that's on Zoom, and you might be getting some feedback from there.
Maybe if I move this a little. Yeah, it's too close. Oh, wow, it's disconnected. Wow, why did you do that? Yeah. You got my call. Are you trying to do two devices at the same time? Yeah, because the video is better on this one, the audio is better. Okay.
You might have to. One of the audio.
This one's music.
Do you have sound coming out of both devices though? You're gonna have to turn the volume down on one of them to 0. That way they don't feed back to each other.
All right. I hope that's better now. I'm not hearing any feedback anymore.
Yeah, that's it there. That's it.
All right, cool.
Perfect.
Okay, so
Perfect.
thank you so much. All right, so I was saying for table 1, it's asking for your estimates. So if you already fill those in, that's great. But I'm going to go ahead and measure the pH for table 2. Okay, so you can put in your estimates now or as we go along, what you think the pH is going to be. But I'm going to be using pH paper, and we'll find out what the actual measured pH is. Okay. All right. So this first solution is HCl, hydrochloric acid. I'm going to dip the pH paper in there. And this is the color that I get. Yeah, see that? Okay. So it's a deep orangish red, and it seems to match up with pH 2 on this scale. So this is the color scale that we use to compare. The colors match when we have a pH. You'll agree that it looks like. Okay. All right. So HCl we have pH 2. I'm going to have your this other one so you can compare for yourselves. Okay, HCl is pH 2. Our next solution, HNO3. I'm going to put the pH paper in. Here's the color of it. Another deep red. To me, this time it looks closer to pH 1. You don't have to agree. You can compare it to 2. It's either 1 or 2. You just match the color, whatever color matches, that's what it is. Okay, you'll see one. All right, you can keep it a stretch. All right, our third solution, H3PO4, that's phosphoric acid. Putting the pH paper in there. Here's the color that I got. Reddish. Red that looks to me like pH 2. So pH 2, that's what I'm seeing for phosphoric acid H3PO4. Again, you can make your own determination. I'm just saying what I see. All right. If you missed something, let me know. After each table, I'll repeat everything in the chats in case you missed anything. Our fourth solution, NH4Cl, that's ammonium chloride. Putting the pH paper in. This is my color. It's yellow, orangish yellow. To me, that looks like pH 7. Could be 6. You can disagree if you think it's 6, but to me it looks like pH 7. All right, so I'm showing the scale. So if you don't agree with my color matching, you can make your own. You can come to your own conclusion. All right. That's okay. That's what it is. That's completely fine. All right, our next solution, NH3, that's ammonia. Putting the pH paper in. Here's our color. Really deep blue. Oh, when it gets this deep, it's kind of hard to tell. I'm gonna go with 13. That's what it looks like to me. So this is 13 here where the stick is matching. If you disagree, 14 is to the right, 12 is to the left, and 11 and 10 going down. It's okay if you disagree with me, so long as you have a number there that closely matches what you see. All right, I have well some. Okay. It was darker. I promise.
What you said it was?
It looked like 13 to me. I can do it again and have it to you right away. Now it looks like 10. Okay. Good. Okay. And then the last solution for this section, NaOH, that's sodium hydroxide. Tap, tap. Another deep blue. Now to me that looks closer to 12. Yes. I'm saying 12. If you see something different, that's fine. So deep blue, that's highly basic. What are we saying? Cool. Okay, so for table 2, you should have 6 pH values for the 6 solutions. Based on those pH values, you just write A if it's acidic, B if it's basic, and S if it's a salt, which would be ideally neutral or close to neutral. So remember, acidic is from 0 to 6. 7 is neutral, which is most salts. And 8 to 14 is basic. All right, so I'll give you a minute if you want to do that right now. Then you can see how close you may have been with your estimates from table 1. Okay. If there's no questions, let's move on to part B with table 3, right? So in this section, we're neutralizing the acids from part A. The acids were the first three solutions. Those were the ones that gave us pH values less than 7, right? So our three acids would be HCl, hydrochloric acid, HNO3, nitric acid, and H3PO4, phosphoric acid. And for this section, we're going to see how many drops of sodium hydroxide, NaOH, that's needed to neutralize 10 drops of each of those acids. I've already added phenolphthalein indicator to all three of these, so that when it's neutralized, when it reaches that endpoint, we're going to see a faint pink color appear. And that's how we'll know that it's been completely neutralized. So again, for table 3, you can write the number of drops you predict will be needed. And I'm going to go ahead and start adding drops, and I'll tell you how many actual drops were required. Okay, let's start with HCl. Boom. Drops. So just 2 drops, and I'm already seeing a pale pink color appear. So 2 drops and it's neutralized. It's okay if your predictions are off. That's perfectly fine. But if you're consistent, then you'll see a pattern appear. Okay, so for HCl, only needed 2 drops. Let's go to our next acid, nitric acid. Okay, HNO3, our second acid, I added 10 drops. So if you predicted that we need more drops of NaOH for nitric acid, you'd be right. 10 drops. All right, let's do our third acid, which is phosphoric acid. Let's see how many drops we need this time. Let's see. 12 drops. 12 drops. There's our pink color. It's nice and faint. 12 drops of NaOH needed to neutralize phosphoric acid. All right. Before we go on any further, I'm going to write all the results down in the chat. Question there. Destiny, the first acid was HCl, hydrochloric acid. And the second acid was nitric acid. Okay, so two. Okay. Okay, we're moving on to part C. Unless there's any questions, I just put the results for tables 2 and 3 in the chat. If you have any questions, let me know, but we're moving on to part C. So we're filling table 4. This one is to measure the pH of metal salts. So again, you want to put your predictions as to whether these solutions for part C are going to be acidic, A, basic, B, or neutral, N. You can put them in as we go along. Let's go ahead with the first solution. Sodium carbonate, Na2CO3. There's that pH stick dark blue. To me, that looks like an 11. You can see over my glove. I'm seeing pH 11. So would that be acidic, basic, or neutral? A pH of 11. You can put in the chat if you don't want to speak up, that's fine. Something has pH 11. Is it acidic, basic, or neutral? Basic. Very good, man. Thank you. All right. So that first one we got pH 11. All right, let's do our next solution. Sodium hydrogen carbonate, NaHCO3. Our color green. It looks to me like 9. Looks most like 9. Let's see. The color to me looks like more like 9 than 8. So I would say, but you can disagree. Okay, it's not our next solution. Sodium chloride, NaCl. That's table salt. Also, this is just salt water. Here's the color I get. A big yellow. To me, it looks like 6. That looks like page 16. So okay if you disagree. I don't have my glasses today anyway. There's the stick. There's the stick. Okay. Yeah. Okay.
What did you say? You thought it was 6?
Yeah. What's it look like?
7.
7? That's fine. That's fine. All right, we have 7 in the room. If you're wondering. So I say 6, the other folks say 7. All right, our next solution. Iron chloride, FeCl3. There's the color. Oh, that's a strong 2. That's a 2 for me. So you probably can tell this isn't like the most accurate way to measure pH. Because colors come in a lot of different shades. Sometimes the colors will be in between 2 of the boxes that are here, you know? So really, whatever you think it is, close estimate is just fine. I'm seeing pH 2. But if you think it looks more like pH 1, that's okay. It's probably 1.5, but we can't say because there's no in-between numbers. It's all whole numbers on this scale. So I'm gonna say 2. All right. Unanimous pH 2. Okay, our next solution is sodium phosphate Na3 pH 4. Here's the color. See 13 again. I'm saying pH 13. If you think it's more like 14 or more like 12, that's fine. Oh. It's really not making too much sense. Just let it go. All right, our last solution for table 4, sodium dihydrogen phosphate, NaH2O4. All right, here's our color. Orange or bright orange. So really, it's like 4. But you write what you think it is. What was the one before this one? So we just completed table 4. Let's see. Table 4. See how drastically the pH changed, adding 2 hydrogens to that phosphate compound. So Na3 PO4 gave us a pH of 13, but NaH2 PO4 gave us a pH of 4. Big difference. Just adding 2 hydrogens. Okay. There's no questions. Let's go on to part D1, filling in table 5. All right, so for part D1, we have 3 different metals: zinc, magnesium, and copper. And we're gonna add enough concentrated HCl, enough hydrochloric acid to completely submerge the metal. And we'll see what happens when we do that. HCl. So in this first tube, we have zinc, which is a gray powder. It's a gray powder form. Let's add some acid. Let's see what happens. Okay, so I'm seeing some bubbling. You see it. There's a lot of bubbling going on. Bubbling means a gas is being formed and released. Usually when we react metal with an acid, the metal displaces the H, and the gas is released. If you know what gas that is, that would be great. It's still bubbling.
So it reduces the H.
Yes, the metal displaces the H in the acid, and the gas is released. So you should know, I'm hoping you know what the gas is. Just know that that's what's causing the bubble. So table 5, you write your observations, you write what you see. Right? And all we're seeing is the evolution of gas. Bubbling. It's not super intense, but it's still going. I would call it slow, steady bubbling. And it's going to keep going until all the metals, all the zinc is consumed. We'll know the reaction is over when all the bubbling stops. It's still going. It's still going. All right, hopefully we got that. You can come back and check on it afterwards. But for now, that's what's going on. Okay, our next metal is magnesium. I don't know if you can see it, but there's a little strip of magnesium. It's gray, again, a gray metal. At the bottom, let's add 6 molar hydrochloric acid and see what happens. Okay, we seeing that? So we have some intense bubbling going on. And there's fumes coming out all the way up to the top of the tube. And I can hear it fizzing. And the tube has gotten warm. So the second row of table 5, reaction with magnesium. It's gone, it's over. There's a small piece. The second row of table 5, reaction with magnesium. We observed bubbling. We saw fumes coming up out of the tube, so there was a visible fume. You could hear fizzing as the gas was being released, and the tube got really warm. So there was a release of heat as well. Heat was released, the temperature increased. So those are your observations for magnesium reacting with 6 molar HCl. Okay, let's do our third metal, it's copper. I have a little coiled up piece of copper wire in there. Let's add some 6 molar HCl and see what happens. I'm sorry, my camera skills aren't the greatest. And of course, copper is copper brown. So no bubbling, no heat. But it looks like the acid basically cleaned the surface of the copper. Okay, so it's kind of like this dirty brown before, but in the acid it looks shinier, basically. This dirty brown before, and there it looks clean. Other than that, no other observations. So I'll write that down for you. Type B1, table 5. So basically, that's a much slower reaction. That means most likely the acid can only react on the surface of the metal. And it's not powerful enough to get all the way through it like with the other metals. Okay, so That was table 5. The observations are in the chat if you didn't hear or see everything. Let's move on to part D2. So for D1, the acid stayed the same, right? And we just tried reacting it with different metals. For this part, part D2, the metal's gonna stay the same. So we're gonna use zinc every time, but we're going to use 3 different acids, and we're going to use those acids at 3 different concentrations. All right, so for this table 6, I will be going across the table from left to right, row by row. So we start with 0.01 molar of phosphoric acid. There's already zinc in there. Let's add some acid and see what happens. Just enough to submerge it. Shaking it around to expose all the surface area. Really nothing. It's just mixing, nothing's happening. It's not warmer, there's no bubbling, no fuming, no fizzing, nothing. So no visible changes on this first one. You agree? See anything? Yeah, it was in powder form, so it's kind of dispersed a little bit. But other than that, it's just it. All right, let's go across 0.01 molar HCl this time. So again, the zinc is already in there. Let's add the acid and see what happens. All right, it's completely submerged. Shaping it to expose maximum surface area. So it's dispersing a little bit, but again, nothing really happening. No bubbling, no warmth, no fizzing, no fuming. It's just sitting there. So far it looks like this concentration of acid so far is too low to see any real energy happen. Good. All right, let's go across 0.01 molar H2SO4, which is sulfuric acid. All right, the zinc powder is in there. Let's add some acid and see what happens. All right, it's submerged. Again, not really seeing anything. It is not getting warm, so there's no temperature change, no bubbling, no fizzing, no fuming. There are no visible changes or no observable reaction, whatever suits your fancy. All right, so at this low concentration, it seems that even if you change the acid, it's still not enough of a physical reaction at this concentration. All right, let's go on to the second row, where the concentration is 0.5. So 0.5 molar H3PO4. Something's in there. Submerge. Oh, I can see some bubbling. Maybe I'm shaking too much for you to see. There's a little bit of bubble. Can you see which one it's on? If it's warm. No. See the little bubbles?
Yeah.
It's just a little bit, yeah.
Same thing on our IP.
Sorry?
Still hydrogen release.
Yep. Yep. There's a still metal plus acid. We always get salts and hydrogen. So the new salt here would be zinc phosphate, H2 base. All right, so again, that second row of table 6, reaction between zinc and 0.50 molar H3PO4. All we're seeing is some slow but steady bubbling. So it's bubbling just really just a little bit. So really slowly, really small bubbles. All right, let's move on to HCl. HCl. Submerged. That's my bubble right there. No, I'm not seeing anything happening. Well, it's dispersed through powder a little bit, but no visible reaction. So 0.50 molar HCl reacting with zinc. No visible change. No visible change. Okay, let's go across again to 0.5 sulfuric acid. So submerged. Seeing bubble, again, really slow and steady. So where you see clumping on the screen is the gas pushing the metal up towards the surface of the liquid. So 0.50 molar H2SO4, sulfuric acid, reacting with zinc. Is it warm? It is not warm. All we're seeing is, again, some slow, steady bubbling. So that would be observation. So notice we're seeing more reactivity as we increase the concentration. concentration, right? So let's move on to that third row of table 6, where our acids will have a concentration of 3 molar. Let's start with phosphoric acid, H3PO4. All right, we got bubble. That's pretty immediate. Again, the metal's clumping up at the top because the gas is pushing it up towards the surface. It is not warm. Doesn't feel warm to me. Yep. See it? So then just some bubbling coming from the bottom where the powder was. And as it releases the gas, it gets pushed up towards the top of the liquid. Okay. Moving across our next acid at 3 molar concentration is HCl. Three molar HCl. Let's see what happens. Bubbling again. Same thing. Kind of slow but steady. Exactly. Slow, steady, bubbling. No gas, no fume, no fizzing. Our final acid for table 6. Sulfuric acid, concentration of 3 molar. Let's see what happens when it's added to the zinc. Bubbling. Smell it. It smells. Okay. Does it smell? Right? Ammonia. It's not as strong as ammonia. It's like sharp. Yeah, I don't know how else to say it. It's sharp. All right, so for this last one, 3 molar H2SO4, we have some steady bubbling. This is probably the most intense bubbling we've seen for this table. It's really steady. I heard fizzing at first. We can smell, there's this like like sharp scent. Someone described it as like ammonia-like, but to me it's not as pungent as ammonia, but certainly some smell. So those are your observations. Steady bubbling, seems still going. Instant fizzing, and a sharp odor. Smells like dry mouth. I don't know how that makes sense. That's up to me. Okay. Do you have observations for everything? So I can repeat it in the chat. Okay. Art 2, 6. What was the first one? 0.01 more H3 the observations for 0.01 more H3 beautiful. What do you okay, for HCl, at that same concentration.
No visible changes.
Is H2SO4.
No visible changes.
Okay, at 0.5 more H3PO4.
Bubbling slowly and steady.
That's it. Okay. HCl
No visible changes.
is SO4.
Slow, steady bubbling.
Zero more H3PO4.
Slow, steady bubbling.
HCl.
Slow, steady bubbling.
H2SO4.
Steady bubbling with a start off fizzing and then sharp odor.
All right. Observations for table 6 are in the chat. Whew. Okay, table 7 and D3 is for your predictions again. So I'm going to give you a minute to write numbers 1 through 6 across table 7. So you write 1 where you think the reaction will be the fastest, 6 where you think it'll be the slowest, and then 2, 3, 4, and 5 in between, right? You might have an idea how to go about that based on what we've seen so far. Look at your observations for where magnesium has reacted. Look at how zinc has reacted in comparison. Which one has reacted more strongly? Which one has given faster reactions, right? And then compare again between those 3 acids. Which one has usually given us the fastest reaction, the most observation driven, the most intense reaction? Right, so it doesn't really matter if your predictions are wrong, just put some thought into it and see if things play out the way you predict. This is the last part of the experiment, so once you have your predictions ready, we'll go ahead. Again, it's okay if your predictions are wrong. We're not asking you to be psychic, we just want you to think about what you've seen so far. All right, you ready? Are y'all ready? Okay. All right, table 8. And again, we're going across. So let's start with 3-molar phosphoric acid. And add it to the cube with magnesium. Okay, so there's a little strip of magnesium at the bottom here. All right, we got bubble. Get fizzing too. It feels a little warm. So to me, it feels warm like at the surface where the metal is. Feeling warm. You got here fizzing. Okay. All right, there's our observations. So go. So we have intense bubbling here. Fumes coming out, it's fogging up the tubes. Really. You can hear fizzing, and the tube has gotten warm pretty much at the surface where the metal is moving around. So that's our observations. We should expect magnesium to react right away. That's what it's done so far. All right, let's try the same acid, but this time with zinc. All right, we got some bubble. It is not intense. They're really small bubbles. No fizzing, no warmth. All right. So compared to this acid reaction with magnesium, I would say the zinc one wasn't as fast. Bubbling wasn't as intense. There's no release of heat. The tube did not feel warm. No fizzing, no fuming. Just bubble. Okay. What's the next acid? as for our next acid, table 8, that second row, same concentration, but this time our acid is sulfuric acid, H2SO4. All right, so there's a little square of magnesium in here. Let's add the acid and see what happens. Ooh, good. So very intense bubbling. You can hear fizzing, and you can see some fumes coming up inside the tube. Well, let me know if it's warm. And if the tube's warm. Okay. So lots of observations for this one. 3 molar H2SO4 with magnesium. We have intense bubbling, fumes forming. We can hear fizzing. And the tube has gotten warmer. So heat's being released during this single displacement reaction. It's gone anyway. All right. So that reaction was so fast, it's over already. The little piece of metal is completely dissolved. It's gone. So that's probably the quickest reaction we've seen so far. All right, moving on. Same acid, same concentration, but this time the metal is zinc. So let's add that acid and see what happens. Yeah, but it's going to be over soon. The metal's clumping up near the top again because of the bubbling. So it's going pretty fast. But the bubbling is not as intense as it is. You should still be able to get it. Is it warm? Not good. Okay, so that was 3 molar sulfuric acid reacting with zinc. We saw fairly intense bubbling. There was some faint fizzing. That was about it. The tube was not warmer. There was no fuming. I can still hear the fizzing. It's still bubbling, as you can see. So the powder was at the bottom. As it reacts with the acid and the gas is released, it pushes the solid up towards the surface of the liquid. And it's going to keep going until all of the metal is concealed. All right. Now to our last acid, which is 3 molar HCl. Hydrochloric acid. Let's see how hydrochloric acid reacts first with magnesium. So there's a little square of magnesium at the bottom of the tube. Let's see what happens. It's been bubbling. Fizzing. Let me know if you can hear that. About 1 or 2. So that little strip of magnesium, little ribbon that was at the bottom, it's reacted immediately. Intense bubbling, steady fizzing, and the tube is a little. It's going to keep going on screen until the metal completely dissolves, then it will stop. So that piece of metal is getting smaller and smaller. Still fizzing. There's still fumes coming up out of it. Ooh, it's hot. And heat is being released to keep us up and warm. So your observation would be that the tube is warming. The conclusion that you draw from that is that heat must be being released. All right, so intense reaction here. And our very last combination, 3 molar HCl reacting with zinc powder. Bubbling straight away, but not as intense. But we could have predicted that. It's a little fizzing, it's faint. The bubbling is also slow but steady. Really small bubbles. And the same thing is happening where the metal is like jumping up towards the surface of the liquid. So if you shake it, it'll go down to the bottom. And then if you watch it, it'll float back up to the top because the gas is pushing it up towards the surface. So your observation would be steady bubbling, not as intense as it was with magnesium, but steady bubbling, faint fizzing, because I heard a little fizzing, and that's about it. No warmth, no fuming, nothing like that. All right, let me write that in the chat in case you didn't see or hear some of that. So that was part D3 to the what did we say with magnesium for the H3PO4? Sorry?
Intense bubbling and fizzing.
Okay. With zinc.
No heat.
No heat. What else have you?
How's that right now?
What do y'all have for 3 molar H3PO4 and zinc? What's your observation? H3. Uh-huh.
Slow bubbling. It was cold, not sleeping.
3 molar H2SO4. What happened with zinc?
Fairly intense bubbling.
With what physics?
Faint.
Okay, and with magnesium. So, was that magnesium you just told me?
That was zinc.
That's it. Oh, okay. Magnesium.
Intense bubbling. And finally, fizzing with warm tea.
It's what happened with magnesium?
Intense bubbling, steady fizzing, warm tea.
And
Steady bubbling and fizzing.
All right, observations for table 8 are in the chat. That concludes the experiment. If you have all the information, all the data that you need, you're done and you're free to go. If you have any questions or if you're missing something, if something is not clear or it's not in the chat, if you want to see a tube again, I'm here to just let me know. Thank you and same to you. The half-life, yeah, that's fine.
Nice work once again. All right, can I go ahead and close it out?
Sure, I don't see any questions.
All right, cool. Thank you. Have a good evening.
Thanks so much.
All right.